Hello all. Today we'll be continuing the discussion with respect to natural language processing. From the previous videos of various concepts that we have discussed like stop keywords, lemmatization, stemming, then we saw something of count vectorizer. We saw something called as bag of words, how we can implement bag of words by using count vectorizer. And then we also saw TF-IDF model. Now we will try to implement a project, and the project is basically called as how basically we'll try to create a model which will be like a spam classifier. This kind of spam classifier will actually classify your spam messages that you usually get in your email, or suppose if you're getting a text message which are kind of spam, this spam classifier can actually detect them. So we'll try to see that, and today this is a whole machine learning problem statement as of now, and I'll be discussing about this machine learning problem statement. We will be starting from reading the data set. I'll just explain you of the data set from where I have taken this particular data set, and then we'll follow all the processes of stop keywords, lemmatization, stemming, and then try to apply a machine learning model, and then try to find out whether this message is a spam or not. So basically, in this particular data set, I have taken from UCI website. Okay, there is a machine learning repository over here, and you just search in Google for SMS spam collection data set, and you will be getting the complete data set as it is. So you can download this particular data set. As soon as you download, you'll be getting two folders, and your two folders will be looking something like this: spam collection, and there will be something called as SMS spam collection. Okay, now if you just go, this one is the readme file. Readme file has some information about this SMS spam collection. Okay, and when you try to open this particular this particular file, and if you just do edit, you can see that here is your whole data. Okay, I'll just zoom in. Here is your whole data. The first column basically specifies that whether it is a spam or whether it is a ham. Ham is just a category it has taken, indicating that this message is not a spam. The second column will basically be having your message. Okay, this will be your spam message. Okay, and the first column basically specifies whether this message is a spam or a ham. So this is our data set. Based on this particular data set, what we will do is that we'll try to create a model, and then we'll try to predict whether any messages are ham or spam. Okay, so that is how we are going to use this. Now the first thing that I want to discuss about this particular file is that how do we read this file. Now in this file you can see that it is tab separated, right? So here you can see that this column and the whole message is basically tab separated. It is not space separated, instead it is tab separated. The reason why I'm telling you tab separated, because when you try to read this particular data set, okay, by using read_csv file, we'll try to put a delimiter, that is /t. /t indicates tab. Now let us just continue and try to see how we can read this particular data set. Now you know that I have a folder called as SMS spam collection, and this is SMS spam collection file. Okay, so what I'll do is that first of all I'm going to import my pandas. Okay, pandas, because I'm using pandas for reading this particular data set. Okay, the next thing is that I will use pd.read_csv, and I'll give the whole path of this particular file, and I know that it is present inside SMS spam collection. Okay, and then I'm going to use the separator which is called as /t. Okay, so /t basically says that the first and the second column, over here the columns are actually tab separated. Okay, so this /t will actually help you to divide this into two columns. So this will be your dependent feature, and remaining all the content with respect to the message will be your independent feature. And when you see this all spaces, these are basically spaces, just blank spaces. Okay, and these are /t, because if you just try to open this file in Notepad++, at that time you can see that there will be a /t over here written as well. Otherwise all the other spaces are just space, normal space or blank, you can say. Now what I'll do is that I'll use the separator /t, and since I don't have any column names over here, I'm going to specify my column names, saying that the names is equal to, and I'll provide two labels. That is, for the first column I'll specify label, and this label will basically be having spam and ham. Okay, and the second label will basically be my message. So these are my labels of the two columns that I'm going to use. Now as soon as I read this particular data set, you see that how our data set will be created. So once I execute this, here is my variable explorer. I'll just go and see my data. It is something like label and message. Now you can see that my data frame is basically having two columns. One is label and one is message. In the label, I have ham, spam, okay? And in the messages, I have normal messages, okay? And this particular label indicates whether this message is a ham or a spam, okay? Now the next thing is that, as I told you, as we discussed in the previous NLP playlist, right? If you have not seen the playlist, guys, please go and see those playlists, because I'm going to use those concepts and I'm going to implement this whole use case, okay? Because I'm going to use stop keywords, I'm going to use lemmatization, sorry, I'm going to use stemming, I'm going to use, I'm going to create a bag of words. So all those concepts have been discussed in the playlist. If you have not gone through that, first of all, go through that, then you come and try to understand this particular use case, how I've integrated all these concepts. Now, the next thing is that I'm going to do some data cleaning and data pre-processing, okay? Now, in this messages, if I go and see my messages column, okay? Now, in this messages column, we have a lot of things like comma, full stop, and many letters are there in capital letters. And we also have question mark. And we also have some of the words like the, to, and, we, do. Actually, these words are not that much responsible to indicate whether that message is a spam classifier or not. We just have to focus on some of the words. And first of all, we have to first lower up all these words that are present in this particular sentence, because there will be scenario that you may have this, if you don't lower it up, then there will be a problem that you'll be having duplicate words with different, some words will be in capital letters, the same word will be in small letters. So that kind of scenario may come. So what you have to do is that in data pre-processing, first of all, what I'm going to do, I'm going to import RE. RE is basically a library which is used for regular expression. The next library that I'm going to use is NLTK. Now, I hope you all know why NLTK is used, because everything, when you're using stop words, when you're doing lemmatization, when you're doing stemming, whenever you're doing bag of words, all the libraries are present inside NLTK. Okay, so you don't have to worry about that. Sorry, with respect to bag of words, we'll be using scikit-learn, but most of the libraries like stop words, and some more libraries like stemming, lemmatization will be present inside NLTK. So make sure that you import this NLTK, and I hope you have downloaded the NLTK from my previous videos if you have seen that. If you have not seen that, just see that how to download all the libraries. So you can just execute this to download the stop words, but in my case, the stop words are already downloaded. Okay. So what I'm going to do is that next, from nltk.corpus, I'm going to import stop words, because stop words, as I told you, that there are some words in these messages like the, if, of, then, okay, small words which are of no use, like in, a, to, okay, all these words, I have to remove it from here. So I have to import stop words, and stop words has all this kind of words over here. Okay, so what I'm going to do is that first of all, I'm going to import stop words. Then I'm going to import protostemma, and protostemma is basically used for stemming purpose, and stemming is basically a technique which will help you to find out the base root form of the word. Okay, so here I'm importing protostemma, and I'm initializing the variable of protostemma, that is ps. Okay, now my next line is basically I'm creating an empty corpus, because after data pre-processing, all the messages that are present inside this message data frame, I'm going to put that up in this corpus list. Okay, so now let me just show you how the data cleaning process is done. So as I told you, first step is that I will remove all the unnecessary characters like numbers, full stop, comma, okay, full stop, comma, dots, or exclamation mark, question mark. I'll try to remove everything from here. So for that only I have imported this regular expression. So what I'll do is that I will run a for loop on all the messages, that is 5572 records. You can see over here, there are 5572 records. If I just scroll down, there are 5572 records. Okay, so for all this, I'll just put a for loop, and on each and every message, I will try to remove. I'll try to remove all the characters except A to Z and capital A to Z. Basically, except small a to z and capital A to Z, I'll remove all the other characters and I'll replace it with blank. That is what this re.sub is doing. Okay, and here you can see that I'm giving messages of message, right? Messages of message of I. So this I will basically help you to indicate basically whether you are in the first loop, you'll be in the first sentence. then in the second loop you'll be in the second sentence. So this I value will be changing based on which sentences you are in. Okay, so that is the first step. You are removing unnecessary characters like full stop, comma, punctuation, dot dot dot, or if you're putting any special character, everything will get removed apart from these characters. Okay, now in my next sentence I'm going to lower up all these messages. I'm going to lower up, I'm going to lower all the words in these messages. Okay, so that I do not have any duplicate words. The next thing is that I'm going to split each and every sentences where I'll be getting, list of words, because I have to apply now stop keywords and stemming on each and every word, right? Stemming will help you to get the base root form of the word. So what I'll do is that first of all, I'll just split this particular sentence. I'll get a list of word in review. Then what I'll do is that I'll put a condition for word in reviews. Since I have list of words, I'm going to put a for loop where I say that for word in reviews, if that word is not present in stopwords.words of English type, if that word is not present in this stopwords.word, I'm going to take that word and I'm going to apply the stemming process. Okay, I'm going to apply the stemming process. So as soon as I apply the stemming process, I will be getting the base form of that particular word. Okay, suppose if if it is written intelligently, you may be getting something called as intelligent. Okay, or if there is a word like going, it will become go. Okay, so that will actually be done by the stemming process. Then in this review, I'll be getting again the list of words which will be in the base root form. And remember, all the stop words will be removed from that whole list of words. And then I'm going to join that words. Okay, I'm going to join that words. Sorry, I'm just going to join that all the list of words into a sentence. And then I'm appending that in my new list that I created, that is called as corpus. So that is all the steps that I'm actually doing. So first of all, let me just execute this whole statement at once. Sorry, it is saying import RE is not defined. So just go and import RE and NLTK. Sometime error is good for health. So I have executed it. It will take some time since there are around 5,572 records. I think it should be happening within 5 to 10 seconds. Let's see. Always remember, guys, remember the steps over here, what I have done. First of all, I have done the cleaning part. Then I have done the lowering part. Then I have done the splitting part. Then for each and every word, I have found out whether that word is present in the stop words or not. If it is not present in the stop word, I have actually, moved to the stemming part, and I have found out the stemming or the base root form of that particular word. Finally, I have joined all the words and appended it into another list, which is called as corpus. Now it has got executed. Now let us see corpus over here. Okay, so this is my corpus, and this was my real messages data frame. Okay, now you can see that there are a lot of words, like see this go, until has got removed since it is in stop words, right? 0 point crazy, CRAZY has become CRAZI due to stemming. Okay, what you can do is that you can also apply lemmatization, guys. Okay, it is not compulsory that you only have to apply stemming, because usually stemming takes less amount of time. But let's see, if the accuracy is bad, definitely I'll go and move towards lemmatization. But initially I'll just try with stemming. Okay, so this is my new text, that is my corpus. Now my data is actually ready. Now this data, after cleaning, I'm going to convert into bag of words. And bag of words, if I say bag of words, you should remember that in the previous class we have discussed about bag of words. It is nothing but a document matrix with respect to the words. Again, the explanation is given in the previous videos about how to create a bag of words, guys. Please see that. I'll provide the link in the description box about the NLP playlist. Okay, and please go and see that also. Okay, now next thing is that what I'll do is that I'll just create a bag of words or the document matrix. Now for that, what I'm going to do is that I'm going to import a library which is called as count vectorizer, and it is present inside sklearn.feature extraction. Okay, sklearn.feature extraction.text. I'm going to import this count vectorizer. Now when I'm initializing the count vectorizer, I'll just remove this max features for right now. Okay, I'll not have max features right now. Now just see this, what will happen. Okay, as soon as I'll first of all initialize this count vectorizer, and my object is CV. and then I'll do fit transform on this new list that I've created, that is my corpus. Okay, and I'll convert it into an array. Now you see this, as soon as I execute it, okay, now you can see that my x data, which is my training data, okay, how many unique words I have, how many total number of columns I have over here. You see this, how many total number of columns I have somewhere around 6296 columns. Okay, now when I have 6296 columns, I told you that I have to take the most frequent elements, because there will be some characters where there will be somewhere like words like some of the names which may be coming just once or twice, right? And there will be some of the words which will be just it will not be that frequent when compared to the other words, right? So because of that, we should not take all these columns, that is 6296. Instead, we should just select some frequent columns or some frequent words, right? Now this 6296 basically indicates that in currently in my x data, okay, in my x data, they are 6296 words, separate words, that is indicated by column. If I move towards the right, each and every represents one word. Okay, and with respect to this words, I'll be having ones or zeros that will be present over here, right? Now because of that, what I'll do is that now I don't need 6296 words. The reason is that I know that only some of the words may be frequently present. Okay, sorry, some of the words will not be more frequently present. It may be either one time or two time present. So what I'll do is that I will just take, I'm just selecting some random max features. So I'll just say that instead of 6296 columns, I want to just take 5000 columns now. Okay, top frequent columns, basically I'm just taking it as 5000. You can change it, so you can play with it. Okay, you can just take a little bit more higher and see how the accuracy is coming. So what I'll do is that instead of taking 6296 words, I will just take 5000 words. Now when I execute this, to see that, now you can see that my x has now got converted into 5000. Now I basically means that I'm just taken the top 5000 most frequent words from the when comparing to all the features, right? In that particular whole documents or the sentences that I had, what I'm doing is that I'm taking the most 5000 elements, most frequent words. Okay, and now you can see that this is my data set. This is my whole training data set. This is my whole training data set. Sorry, this is my whole data set altogether. Now you can see that some or the other way ones will be present. Okay, since there are many words, I can just show you exactly where. But if you just explore it, okay, just let me just show you one, at least one. I'll try to show you. Some or the other way it will be present. Okay, you can see over here, one has present. So this basically means that this column, which is indicated by that word, it is present in this 491 sentence. Okay, in 491 sentence, this word is present. That is what it is indicating. So its count is 1. Okay, so this is how your whole document matrix looks like. Okay, and this is actually created. This is also called as bag of words. Okay, now this is my whole data. I have my whole data, but what about my output data? My output data is basically my label column where you have ham and spam. Now what I'll do is that I'll take this. Okay, now this currently my x is basically my independent features, right? This is my independent features. Now if I want my dependent feature, I have to take this label, right? So for that, what I'll do is that, and one more thing, guys, here I have two categories. One is ham and spam. Obviously I can't just pass ham and spam directly to my model. My model will never be able to understand a string or a text, right? It is not a human being. So we will try to convert this into dummy variables. Okay, and in order to convert this into dummy variables, we will be using something called as pandas.getDummies. So as soon as I execute this, you see this, and I'm just passing the label column. So as soon as I execute this, now you can see that in my y column, I'll get converted into two categories, two columns. So ham will actually get specified with 1, spam will actually get specified with 0. So in all these columns, wherever there is spam, okay, it will get classified with 0. Sorry, wherever there is ham, that is 1. Otherwise, if it is not ham, this will become 0. Okay. Similarly, when spam is there, it will be 0. When spam is not there, it will be 1. Okay. So this basically indicates that whenever okay, sorry, it is not like that, guys. Just a small change in the explanation. Here, after converting into categorical values, it basically indicates that in this spam or ham column, wherever there is 1, that basically indicates that it is a ham category. And in the spam column, wherever it is 1, it basically indicates a spam category. Okay. Now, I have two categorical variables over here, right? But instead of having two categorical variables, if I just have one categorical variable, okay, if I just have one column, I can represent that I can represent the ham part by this column itself, you know, because you can see that when the spam is 0, this basically indicates that this column will be ham, right? So ham value I'm specifying it as 0 and spam value I'm specifying it as 1. So what you can do is that you can remove one column from that. So in order to remove this column, what I'm doing is that I'm writing just y dot ilog colon 1 dot values. So as soon as I execute this and see my y value, you can see that I'm just taking one column, that is the spam or the ham column. You can take any of the column, okay, because one column will actually specify both the information. If it is 0, it basically specifies that it is ham. If it is 1, it basically specifies that it is spam, something like that. So you don't have to use two categorical features, and you can just use one categorical feature. And this is also called as dummy variable trap. Okay, you should not get into this particular trap. And there are some problems with this, which I'll be discussing in the data science interview question. What does it mean? Okay, so now my x, which is my independent feature, is ready. Okay, my y, which is my dependent feature, is ready. That basically means that with respect to this sentence, my first sentence, I'm having value as 0. That basically indicates that this is not spam. The third sentence that I have, that value indicates 1. This basically indicates that this sentence is basically spam. So this is my data. This is my independent feature. This is my dependent feature. Now what I'll do is that I'll just do a train test split. I'll do a train test split because I need to train my model. For doing the train test split, I'll just import the train test split library from sklearn.model selection, and I will make a test size of 20%, 20% of the whole data. So let me just execute this. So here it is, my x train, x test, everything is getting executed, and I have all the data over here. Now you can see that my x test is having 1115, whereas my x train is having 4457. If I add up this, it will be equal to xi. Okay. Now, in order to solve this problem, I'm basically using a naive Bayes problem, because naive Bayes work very well with respect to NLP, natural language processing. But even though we'll not be getting much good accuracy, if we get also good accuracy, we can fine tune it. Again, the theoretical part of naive Bayes, I'll be taking another video session. I'll be uploading another video where I'll be explaining the theoretical concept of naive Bayes. But for just now, you understand that naive Bayes is a classification technique. Okay, it is a classification technique, and it works completely on probability. If I just show you the probability formula, I think you will be very, very familiar with it, because in the high school days we have worked with that particular formulas. Okay, so that naive Bayes will be taken in the later videos, where I'll be explaining you about the theoretical part. But now I'm trying to implement a naive Bayes. Okay, and this is a classification technique, guys. This is basically a classification technique. So for that, I'm going to import from sklearn.naive Bayes. I'm going to import something called as multinomial NB. So this is my naive Bayes library that I'm going to use, and and this basically works for multiple classes or single classes or 2 classes, 3 classes, any number of classes that you want. Okay. So after importing this, what I'm doing is that I'm initializing it, and I'm going to fit this with my train and y train. So after I initialize this and I do the fit, basically what happens is that this will my model will get created. So this is my spam detective model. Okay, my spam detect model. Then what I'm going to do is that I'm going to predict with respect to my test data. That is my x underscore test. So after I predict, you can see that this is my y pred. My y pred variable is created. Now this is my y pred, and this is my y test. Okay. Now what I'm going to do is that I'm going to compare this both. Now you can see that most of the values have been compared, and it is looking almost equal, right? This is my y pred and this is my y test, but there are so many more values. How do we compare it? So for that, I'll be using something called as confusion matrix. So I can write from sklearn dot matrix. I'm going to import confusion matrix. Okay, confusion matrix. If you don't know about confusion matrix, guys, please go to my playlist. I've created a video on confusion matrix. which is just like a data science interview question. Okay, and I've explained completely about confusion matrix over there, very detailedly. It is more than like 20 minutes videos about that. So for confusion matrix, it basically gives you a 2x2 dimension matrix, which will actually say you that how many number of elements are correctly predicted. Okay, so for that I'll just write confusion underscore m is equal to, I'll initialize my confusion matrix, I'll create a variable and then I'll initialize the confusion matrix, and inside this I just have to give my y test comma y pred. Okay, as soon as I give this, you can see that my confusion matrix will give me a 2x2 matrix. So it will give me a 2x2. So here I'm opening it. So it will give me a 2x2 matrix, and the diagonal elements where your value is 0 and the upper value is also 0. See, this is your actual output, this is your predicted output. So 0 0 is getting matched, so you have 946 correct predicted, and you have 1 and 1. This block is also correctly predicted. So you can basically say that 946 plus 152 is correctly predicted out of the total outcome. Now you need to check that how you can check the accuracy score. For checking the accuracy score, you can also use from sklearn.metrics. Okay, and I'll be importing another library which is called as accuracy score. Okay, accuracy score will actually help you to find out what is the accuracy. So accuracy underscore score, or just I'll write accuracy is equal to accuracy underscore score, and here also you just have to give your y test comma y pred. That's it. So once it is executed, what you have to do, you just execute it. Fine. Now you can see that your accuracy is around 98%, guys. See the accuracy, it is wonderful accuracy of 98%. And this is how you have basically implemented a spam classifier here, how I have implemented it. I have just used concepts from basic NLP concepts like stemming, lemmatization. I've not used lemmatization over here, but guys, if you want, you please go and try to use lemmatization over here and try to see in this particular sentence you can use lemmatization and you can increase the performance. But here the accuracy is almost 98%. So it has, we have done a great job and created a good model. Again, there will be some dependencies, like if my spam and ham are not in equal proportion. Okay, at that time, if I have an imbalanced data set, at that time my accuracy may not be good. Okay, so please check if the what else we can do with respect to the how we can improve the accuracy. For that, what you have to do is that instead use lemmatization over here and try to do with lemmatization, try to check. And instead of count vectorizer of creating bag of words, use TF-IDF model if you want. And TF-IDF code, everything is given in my previous videos in NLP. Okay, you just have to go and replace this code over here. That's it. And automatically all the steps will be same and simple. So make sure that here I've used naive Bayes. I told you that naive Bayes will work very good because it works completely on probability, and it does work very nicely for NLP problems. So I'll just let you know about the theoretical concept of naive Bayes in the later stages, okay, and why it works very good with respect to NLP. Also, we'll discuss. So I hope you like these videos, guys. If you have not subscribed the channel, please do subscribe it. This will really give me a motivation to make more and more interesting content and videos for you all. I hope you like this video. Share with all your friends who is in need of this kind of problems, who wants to become a data scientist, and they want some materials to study. Please do let me know, and please do let me know, like, if you want me to create any other videos, I'll definitely do that for you, and I'll meet you all in the next video. Thank you one and all. Have a great day ahead. Thank you.